Hello everyone, welcome to our video today where we will be going over chapter 5 of organic chemistry, alcohols. Now some of these concepts have been covered in the previous video, organic chemistry chapter 4, when we were analyzing reactions, but this is specifically for alcohols and hopefully will give you a little bit more detail. So let's get into it. So we have alcohols, right, that are this OH group. And they have the suffix of OL if they are the highest priority functional group in that molecule. And then we have the prefix of hydroxy if they are not. If they're not the highest priority, they would take this prefix and it would be hydroxy. So then we have phenols, which is basically a benzene ring with an OH attached to it. So you have ortho, meta, and para positioning of those OH groups. So we can have ortho if the OH is there. You know what? I didn't draw the OHs on them, but these are all OHs, okay? But it's more so the positioning that should be looked at. So we have ortho if they are right beside each other, right? If these two groups are beside each other. Then we have meta if there's one in between them on this ring. And then they would be in para position if you have, if they're symmetrical like this at the top and the bottom. So those are the positionings. So, and a couple of other important things. So if we have, phenols are more acidic than other alcohols because of the delocalization that they're able to have because of this ring. And they also can hydrogen bond, which we know is important. So because of those H's, they're able to hydrogen bond. Now electron donating, so the E minus is electron, so the electron donating groups decrease acidity, while we have electron withdrawing groups that increase acidity. And they would increase the acidity because they can stabilize the charge, okay? So these are really important points to just conceptualize everything as a whole. I'll say this part again. Electron donating groups will decrease the acidity, and electron withdrawing groups, right, so very electronegative atoms, will increase the acidity because they can stabilize the charge. So that is definitely important. Next, let's get into quinones. So quinones, they look like this, and they are synthesized through the oxidation of phenols. So if we look at this phenol over here, right? So we remember that Leo says Ger, which means if they're saying it's oxidized, lose electrons, oxidized. So we know that it has to have a loss of electrons or a gain of a bond to oxygen. So if you're going from this to this, you can see that there was a gain of a bond to oxygen, right? Which is why this is why it's been oxidized. This phenol has been oxidized to become a quinone. So it's just conceptually, again, noticing what oxidation actually means. But then you also have ubiquinone, which is actually coenzyme Q, which acts as an electron acceptor in the electron transport chain, which we will get into in later videos when we're talking about that. But just definitely remember this one. So this is coenzyme Q is under the quinones. So again, this part was discussed in the last video, but this is a visual representation and hopefully you will understand it a little bit better. So primary alcohols, right? This OH is attached to only one other carbon. Primary alcohol can be oxidized to an aldehyde. So using PCC. So again, you should probably know the reagents, but just to see what happens. So if it's being oxidized, again, losing electrons or gaining a bond to oxygen, we see that we no longer have the H, right, on this, and we actually gained a bond to oxygen, right? So that is why you can tell that this has been oxidized. Secondary alcohols can oxidize to ketones. Tertiary alcohols are already as oxidized as they can be. So if this is a tertiary alcohol, right, because this, right, OH is connected to these three carbons, you cannot give that another bond, right? It's already as oxidized as it can be. You cannot make another, being a tertiary alcohol, you cannot just easily make another bond to oxygen. So finally, we have alcohols are used as a protecting group. And so acetyls are when you have an aldehyde plus an alcohol. And ketols are when you have a ketone plus an alcohol. And what I mean by protecting group is if you don't want this molecule to react in a reaction, if you don't want it to be touched, you can create a protecting group, right? So here's our ketone plus the alcohol, right, will create this right here, where these will not be there, you know, that space will be occupied technically, right, with this protecting group that was just placed on here, which means as the reaction proceeds, these oxygens will not be reacted with. And then the last step that is not drawn on here is just returning it back to a carbonyl carbon once, you know, the rest of the reaction takes place. So they can also, alcohols are used as a protecting group. That's also an important characteristic of alcohols. So that leads us to the end of this video, but if you have any questions, put them below, and otherwise we will see you in the next video.